In this video, I'm going to look at how we can design a class, a Python class, from a given specification. Well, here we can see we've got a specification. I'm just going to read it through. Whenever a customer joins a bank, an account is created in their name and a balance is set based on how much they deposit. The account must also allow for a deposit to credit the account and for a withdrawal to debit the account. Upon request, the balance of the account and the name of the customer will be returned. Also, once an account is created, the name of the customer can be changed. For example, if somebody was named Rita Jones and they got married, their name could be changed to their new married name. For example, Rita Jones could be changed to Rita Hartley. Once you've got the specification, where do you start? What's your first step in trying to produce a class, trying to build a class that will actually implement the specification given? Well, one of the things you can do is you can look at the words in the specification and identify all of the verbs and identify all of the nouns. A verb conveys an action which we can think of as a behavior, i.e. a method if we're dealing with object-oriented programs. Now, when we talk about a verb, we're talking about a doing word, an action of some kind. And of course, when there's an action going to take place and we want a program to perform that action, we will have program statements that we group together in a method. So when we see a verb in a specification, it kind of implies to us that, oh, I might have a method that will perform the action of that particular verb, what that verb is suggesting. A noun is a name of some specific thing, a state of existence, i.e. an attribute, or more precisely, a data attribute, often called data fields. It's something that is likely to become a variable within our particular class that we wish to build to implement the specification given. Returning to the specification, I'm now going to try and identify all of the verbs and nouns that appear. And these verbs and nouns will then suggest what might be useful to help me build a class to implement this particular specification here. Now, I'm not going to look for all the verbs first and then all the nouns. I'm going to go through the specification one word at a time and stop when I think I've come across a word that I feel is important to help me build a class. And the first word I come across is customer. If I scan through the actual specification, I can see that this appears a couple of more times, as you can see. Now, that's a word that I'm going to extract and write in a list. If I continue, I come across another word here, bank, and I can have a look to see if that appears elsewhere in the specification, and I can see that it doesn't, so I'll carry on, and then I come across account, and if I have a look, I can see that appears numerous times throughout the specification, suggesting to me that this is quite an important word that I need to consider. If I now carry on, I come to this one called created. Now, created is really a verb, isn't it? It's a doing word. I'm going to be creating something, or the program is going to be creating something. So I think that's kind of important. If I carry on, I can see that it appears twice. Now, going again, one word at a time through the specification, I then come on to this here, name. Now, I'll have a quick look at that and realise that this is going to be the name of the customer. Does it appear anywhere else in the specification? We can see it appears twice more. So that's a word that I'm going to use. Now, if I think about the name for a moment, it certainly isn't a verb, is it? It's not a doing word. This is a noun. So that is likely to become a variable in my class. Now, what kind of variable we're going to see later. In fact, it's going to become an attribute in my class, a data attribute in my class, a data field. Now, if I continue through the actual specification, I then come to balance, which, well, I think that's important. Does it appear anywhere else? Yes, it does, as you can see. So balance. Now, what is balance? Is that a doing word? Is that a verb? Well, no, I would suggest that's a noun in the context that we're considering it here, and it's going to be the balance of the account of a particular customer, i.e. how much money they have in the bank. If we now continue through the specification, we can look for other words, and here you can see that I'm highlighting the word set. Now, what does that suggest to me? Well, it's not a noun, is it? That is a verb. It's doing something. So it kind of suggests that I may have in my class definition a method that will be setting something. I'm not saying it will be. What I'm attempting to do here is get suggestions for what will actually be in my class. If I continue, I now come to this word here, deposit, and I'm going to have a look if that appears elsewhere, and you can see it does. So that suggests that's going to join my list. Continuing on, I come to credit, and I think, well, that's quite important. Let's concentrate on this one for a moment. What am I doing here? Well, I'm going to credit. So if I go into the bank and give the bank £100, I want that to go and alter my balance by £100 in the positive direction. So if I had £50 in the bank and I go in and ask them to credit it with £100, I should have 150 after I've credited it. In other words, my deposit was £100 and I'm using the credit as the verb that's going to deposit £100 or however much I'm actually putting in the bank account. So I can see here that there's a relationship between deposit, the amount of money I wish to put in, and credit. So in the context of this particular specification, I think credit and deposit go together. So I am suggesting that there might be a relationship between these when I write the code, and we'll look later to see if that prediction actually comes true. Now, if I continue analysing the specification, I can see I now come across the word withdrawal. If I carry on, I now can come across the word debit. Now, again, I am suggesting that there's going to be a relationship between the word withdrawal and debit. Debit is going to be the verb that suggests a method that's going to receive the withdrawal, which is going to be the amount of money the customer wishes to withdraw from their bank account. So this is the verb that suggests to me at this stage that I'm likely to have a method called debit. And in fact, this withdrawal is going to be a parameter to that particular method. The next name to be highlighted is this one here where it says returned. So I'm going to add that one to the list. Now, in the context of this specification, this is suggesting that I'll need some mechanism to return both the balance of the account and the name of the customer for the account being dealt with. Carrying on, I now come to this one here, which is the word changed, which in the context of the specification means that there must be some mechanism of being able to change the name of the customer. For example, if somebody gets married and they want to change from their maiden name to their married name. Once you've analysed the actual specification and decided what words you want to extract, you'll end up with a list as can be seen here. Now, some of these words are verbs and some of them are nouns. You can, which I haven't done in the video, create two separate lists, one of nouns and one of verbs. It's up to you. It's what you feel most happy with. Now, I'm not suggesting that the class that I build is going to use all of these words that I've extracted from this specification. This is just an approach to think, well, how do I take a spec and how do I get it to a class? And this is just one suggestion. I must say that this is looking at contrived specifications here. If you're going to be designing a software system, then you would have processes before this stage using unified modeling language, and they would define what the classes were going to be, but that's something for another video. What we can see here is we have a mechanism whereby we can analyze the specification, concentrating on verbs and nouns and creating this list. We now use this list, as can be seen here, and we use the list to see if we can derive a class. And I'm going to represent the class in a UML-like diagram, a class diagram, and I'm not going to adorn it with plus signs and negative signs, which define what will be private and public within the class. I'll leave that to a later video. But here, what I've now got are a list of words that will help me build up my class. Now, you can't take these words out of context. You still have to keep on reflecting back on the specification. But I'm happy now that I've got some words that will allow me to think about it, and this is a thought process here. You know, it doesn't just automatically come that you have a class. You've got to think about it carefully. Which of these names are going to be methods? Which of them are actually going to be data fields within your class? And it's entirely up to experience how well you actually perform this task. Using my understanding of the specification and the words listed here, I can now build my class diagram. The first word I'm interested in is the word account, and I'm showing that here. And this is going to be the name of the class that I'm building, the class that I'm designing. The next thing I'm going to consider What are the variables this class is going to require? What are the data fields? Well, I look at all of the lists of words here, and I look at the nouns. And the two nouns I'm particularly interested in is the balance of the account and the name of the customer. So I'm going to put those here, and these are going to form what is often called the data field of the class. These are the variables that are going to hold the balance and the name of the customer. The next thing to do is to have a look and consider where are the verbs. Well, there's two verbs I'm interested in, credit and also debit. And I'm going to show those in the other part of the UML diagram, as you can see here. Now, the credit is clearly, in the context of this specification, a verb. It's going to do something to the balance. So if I put £100 into the bank, the balance will go up by £100, and it's this method here, the credit method, that's going to do that for me. The debit method will obviously reduce the balance by the amount I wish to withdraw. Now here I've got three methods. I've got getBalance and getName. Now getBalance is going to return whatever the balance is of the account at any particular time, and the getName is going to return the name of the customer. The setName, well, what this is going to do, it's going to be the method that allows me to change the name of the customer. Now, these three methods belong to the classic way in which object-oriented programs are written. Within Python, these three methods are often not used, these type of methods I mean, but I'll talk about that in later videos. Here, I'm using the classic approach to the development and the design of a class. And in this case, the class I'm going to use is going to have these type of get and set methods. And they are going to be responsible for returning and setting these data fields. Now, if we look at the credit method, if it's going to alter the balance, it needs to know by how much it needs to alter the balance. In other words, it needs a parameter, and I'm showing that parameter here as the deposit. So whatever is deposited will be added to whatever the current balance actually is. If we look at the debit, well, here, of course, we also need a parameter to be passed to this particular method, and I'm going to call that the withdrawal. So you can see here that I have used the deposit and the withdrawal, which you can see were in my list up here. And I did suggest earlier that I felt there was going to be a relationship between the credit and the deposit, and between the debit and the withdrawal, and hopefully you can see that relationship here. In other words, we pass in the deposit to credit, and we pass in the withdrawal to debit. The responsibility of this method is to allow for the changing of the value stored here. And to achieve that, we have to pass in a parameter. And you can see that the parameter I've put here, and of course this parameter is taken from here in the particular list. As an aside, don't let this confuse you. You see, this is name and this is name. They're not the same thing. This is a data attribute of the class, and this is a parameter to the setName method. And what will happen, whatever's stored in here will be passed to here. Now, we may get confused by the fact that these are both called name, but the interpreter will not. It will know that this is a parameter, and it will know that this is a data attribute. By keeping an eye on the specification and this list produced from the specification, we've now produced this UML class diagram here. And the approach you've just seen will work for any object-oriented language. Of course, these videos are on the Python programming language. So I know that if I'm going to be the programmer converting my UML diagram into code, I will need to have another method. And the method will be this one here, the initialization method. And we can see that this one takes in three parameters. It takes in self, balance, and name. Whenever we create an instance of this class, what will happen is this particular method will execute. And the value passed to balance here, we have to arrange for that value to be assigned to this data field here. Whatever's passed to this particular parameter will be assigned here to this particular data field, this particular data attribute. Now the self, well, we've seen this earlier in the playlist, and self will be passed the ID of the instance being created. Now, I'm not going to talk about self in any detail here. I have 3 videos on this very topic earlier in the playlist. So if you're sitting there wondering what self actually is for, I recommend you go and look at the videos earlier in the playlist. As we will be converting this UML class diagram into a Python class, What we now need to realise is that the word self that I've just been discussing will have to be a parameter to all of the methods that I'm showing here in the diagram, and also self must appear before the data fields balance and name, as you can see here. I've introduced self in all of the places that can clearly be seen in red and bold font. Now, the design approach that I followed in this video has resulted in this UML class diagram. And as a summary, just remember what we did. We read the specification, we then identified the verbs and the nouns in the specification, created a list of verbs and nouns, used both the list and our understanding of the specification to produce this unified modelling language class diagram. The next thing to do is to convert this UML diagram into code. Now, just to show you what the code will actually look like, you can see it at the side here. Now, in this particular video, I'm not going to discuss this code. I'm going to leave that for the next video. But as a summary, just think about designing a class. I've shown you an approach here, and that is read the spec, identify the verbs and the nouns, list the verbs and the nouns, use both the list and your understanding of the specification to produce the unified modelling language class diagram. Now, it is the case that I could adorn this class diagram with more information, but I'm going to leave it in this more simplified state for the time being. Now, in the next video, I'm going to show you how to build a class, the one that you're looking at here, from a UML class diagram. Check out the supporting website for these videos, and also consider subscribing to the YouTube channel and the Google Plus circle that relates to these videos. In addition, why not follow me on Twitter, as I issue a tweet every time I upload a new video.